Hello and welcome. Today we're going to be graphing absolute value functions, okay? So in your last lesson previous to this, you would have learnt how the absolute value function behaves, okay? And you would have learnt this formal definition just over here, this purple one, okay? Now, when you learnt about it, you learned that at its core, essentially what it's doing is ensuring that the output of whatever we put in is always positive, okay? So it always makes stuff positive, okay? So if our number that we put in was above zero, okay, which is by this statement here, so greater than or equal to zero, so we would end up just with the number inside of the bracket itself. However, if we had our number that went into this particular set of brackets here, what we would do is we would add a negative sign to it to ensure that we always got a positive outcome, okay? Now, we're going to use that behavior today to sort of help us graph the behavior of absolute value functions. They're a little bit weird if you haven't seen them before, but we're going to sort of jump into it first, okay? So when I look at graphing this particular function, we're going to break up the behavior over a couple of videos. We're just going to look at this function in this one, and then we'll look at transformations a little bit later on, and then we'll look at solving equations graphically in our final video today. But let's have a little bit of a look at this, and we're going to compare graphing just this particular function here to have a little bit of a fun time with it. So the first thing that we need to do is we need to look at the important value around our entire function and what it centers around, okay? And in this particular case, in our definition for the normal absolute value, everything centers around the value of x equals 0, okay, which is going to happen right around there, okay? Now, let's break this down into a piece-by-piece case, okay? We have case 1, which is this one here, all right? If we have our function of, say, f of x is equal to the absolute value of x, or y equals f of x, whatever you want to say, for everything bigger than 0, we're going to have just the function y equals x. Now, that's something we've actually drawn before. So that's a straight line that starts here at the origin, okay, and just continues going up in that direction. It also goes below the origin. I'm just going to dot this line here because it's going to make a lot of sense for you in just a moment. It goes below the origin in the exact opposite direction, okay, just there for us. Now, there is a reason why I've done a dotted line there, and I will encourage you to do this because it's actually a really important technique for us when we're learning. Okay, what I want you to realize is for everything that we have that is less than 0, okay, so that is that side of the origin, okay, we actually have this function over here, okay, we have case 2 where we have y equals negative x, okay. So y equals negative x is just the same graph that we have here on the right side, except it is going down and sloping to the left. So it looks like this, okay? So let me just get that ready to go. Looks a little bit like that. Now, what I want you to understand why this behavior happens rather than our function going below the origin. Remember how I said at the start of the video that this behavior of this absolute value essentially just ensures that no matter what, we're going to get a positive answer, okay? Either by adding a negative or by keeping the thing the same. So that is why our absolute value function can't actually drop down below the axes, right? It basically hits the axes and then reflects back up, okay? That's essentially what happens. Now, the domain and range of these functions is relatively straightforward, okay? You can see just by looking at this graph, all right? We have the domain is every single x number, right? All real x. So it goes from minus infinity to infinity when we're talking about the horizontal values that we can have for our function. And then for our range, which is the vertical values, remember, we know that it has to be greater than or equal to 0, okay? So essentially positive or equal to 0. And you can see that again just by looking at the fact that it just touches the x-axis and bounces back off. So we have 0 going all the way up to positive infinity, and that's just writing it during interval notation, okay? So that's essentially what happens when we talk about the absolute value graph. We expected it to be a little bit weird because of this piecewise definition that we have over here, but we're going to look at this in a little bit more detail, okay? In particular, what we're going to look at is we're going to look at graphing absolute value functions of the form y equals ax plus b inside of those absolute values, or y equals negative out the front ax plus b. Either one of those. In this particular case, okay, if we have a positive out the front, it is just our absolute value that is pointing upwards. If we have a negative out the front, it's much like a parabola. It just reflects down below the x-axis, okay? In which particular case, the absolute value is pointing down, okay? Some other things that are worth noting is if I add a number out here and a number out here, what I want you to understand is that if the values are inside of the absolute value, our absolute value will move this graph over here left and right, okay? But if it is outside of the brackets, it will move it up and down. So I'll say that again just one more time. If it's inside of the brackets, it will move left and right, and it will move the opposite way of what we think. So remember, if this is a plus, it'll move to the negative sign, okay, just here. All right, and if it's a negative, it'll move to the right, which is the positive side, okay? But it does the same as the number on the outside. So if it's a plus, it'll move up. If it's a minus, it'll move down. Okay, so we're going to have a little bit of a look at that in our a little bit more in our next video. Okay.